All right, so for today's lesson, we're going to be looking at Unit 6, Lesson 3, what a point in a scatter plot means. So here we have this happy panda. Giant panda lives in the zoo. What does the point on the graph tell you about the panda? Well, the x-axis represents the age in months, and the y-axis represents the weight in kilograms. So this means the panda is 36 months old and weighs 82 kilograms. And I really want to highlight, weighs 36 months, is 36 months old and weighs 82 kilograms. Weight and fuel efficiency. The table in scatterplot shows weights and fuel efficiencies of 18 cars. So this graph or data will see how much a car weighs and how many miles per gallon it gets. Where's the graph? You know what? Yeet! Okay. So we got a bunch of different cars and they each weigh different amounts and they each get different MPGs. So which point in the scatter plot represents L's measurements? Okay, well here's L. A, B, C, D, E, F, G, H, I, J, K, L. Here we go. And so it weighs about 1,600 kilograms and gets 19 miles per gallon. So 1,619, I think it's this one right here actually. So that's point L. What is the fuel efficiency of the car with the greatest weight? So we're looking at how many miles per gallon a car gets if it weighs the most. So here's, why during recording? So here's the biggest weight. And what's the MPG on that bad boy? About 16 miles per gallon.
What's up, Kenny?
This is for algebra, Mr. Martinez.
Oh. What up, Lindbergh?
What is the weight of the car with the greatest fuel efficiency? So greatest fuel efficiency means where are they getting the most MPGs, okay? So we're gonna be looking at this one up here. That's getting 30 miles per gallon. But how much does it weigh? I'm gonna say about 1,200 kilograms. Car S weighs 1912 kilograms and gets 16 miles per gallon. On a scatter plot, plot a point that represents car S's measurements. So we're looking at 1912. That would be like approximately right here. And it gets 16 miles per gallon. So actually, that would be about this one right here. That's pretty nice. Point S. Cars N and O shown in the scatter plot are made by the same company. Compare their weights and fuel efficiencies. Does anything surprise you about these cars? So, first of all, let's identify these on the graph. Not the graph, the table. N and O. N and O. So,
What up, Kaide?
oh my god. Let's take a look at them now in the graph. So we're looking at 1987, and it gets 18 miles per gallon. So that's this one right here. You know what? Let me actually highlight it using green. So we know it's that one. And then we're looking at 25 miles per gallon. It might just be easier if we look at the ones that have 25 miles per gallon. And 1432 weight. So 1432 would be right here. Does anything surprise you about these cars? What do y'all think? I'm gonna say nah, which is actually the chemical name for sodium. And you'll learn that in chemistry. A different company makes cars F and G. Compare their weights and fuel efficiencies. Does anything surprise you about these cars? I don't know. Let's look at F and G. Let's use a different color. Let's use green, because green go. I made that joke in my other class as well. F and G. Here's F. And hey, ooh, we don't even have to look at the graph. Notice how they're both getting the same fuel efficiency. They're both getting 16 miles per gallon, which is worse than a Hummer. But they also weigh different amounts. Does anything surprise you? Yes. Why different fuel efficiency? Are you ready for more? Heck yeah! After a board game competition, the tournament director collects 50 dice. Shouldn't it be 50 die? No, it's one die. Multiple die is called dice. Okay. Collects 50 dice from the games played and rolls each one until he gets bored and tries a different one. The scatter plot shows the number of times he rolled each die and the number of sixes that resulted. Select a point in the scatter plot and give its approximate coordinates. Then tell the story of that point in the context of this problem. What? You know what? I'm just gonna ask y'all right now to identify, point at the video right now, which point you think does not belong in the set. Just point at it right now. Okay, I think I know which point you're picking at. You're picking this. Oh, that was so bad. You're picking that point, right? I knew it. Haha, JK. You're picking at this one right here, right? You know what? Let me just highlight it so much it actually disappears. And then I'm gonna erase everything. Whee! That point right there has a special name.
What up, white boy Chris?
Oh my god. It's called an outlier. Hey, no, Jesus. Why am I? Oh, you know what? I forgot. Yup, keep forgetting. A clothing store keeps track of the average monthly temperature in degrees Celsius and coat sales in dollars. So the x-axis represents how cold or how hot it gets, and the y-axis represents how many coats they're selling. So just think about this. If it's colder, do you think they're gonna sell more coats or less coats? And the opposite. If it's hot, do you think they're gonna sell coats or they're not gonna sell coats? So just to give you a heads up, this is something you should have picked up last year. Negative degrees means it's cold. Positive degrees means it can be hot, okay? So what does a point 15,680 represent? Well, when it was 15 degrees Celsius, they sold $680 worth of coats. For the month with the lowest average temperature, estimate the total amount made from the coat sales. Explain how you use the table to find this information. So, we're looking, estimate the total made with the lowest temperature. So the lowest temperature was approximately, let me use a highlighter, orange, right here, okay? And they made approximately halfway between $1,500 and $1,600. When it was negative, what was it? Negative 5 degrees Celsius. They made $1,550. It's a lot of money. For the month with the smallest coat sales, estimate the average monthly temperature. So we're looking where it's the lowest amount money made for coats. That would be this one. If we look at the temperature. God, I can't draw a straight line to save my life. Zoom! I forgot I could do that. It's about 23, okay? It's about 20 degrees Celsius. I know, sorry. We know because the graph says. I can't write outside, so. If there were a point at 0, comma A, what would it represent? Oh, come on, we know this. That's the starting value. In this case, it would be the amount of money made at 0 degrees Celsius. So let's estimate. Let's just say it's A comma something, or sorry, A equals something. So let's zoom in. Let me use a highlighter. Let me use blue. So we're gonna try to draw a line that connects all of these points, okay? Watch me. It's gonna start right here. That was horrible. I hope you do a better job than I did. But where does it cross approximately? And let's just say there. I'm gonna say 1350. A equals $1350. What would the point B comma 0 represent? So B comma 0 would be where the Y value is equal to 0. So somewhere over here. This would represent the amount of heat. Actually, let me say that again. Darn, my English as a second language. The temperature when you sell $0 of coats. How hot do you think it would have to be? You decide. I'm gonna say 30, oopsie, wrong one. I'm gonna say 32 degrees Celsius. Would it make sense to use this trend to estimate the value of cells when the average monthly temperature is 60 degrees Celsius? So first of all, 60 degrees Celsius is like 120 degrees Fahrenheit. That would be hotter than the hottest recorded temperature ever in real life. It already crosses, I believe, the x-axis, right? Let me point over here. It already crosses the x-axis before it gets to 60. Is there such thing as negative money? No. Would it make sense? No. Negative money does not exist. You like that T? That T looks really cool. So, that's actually the lesson for today. It's not that bad. But in reality, remember, you're looking at scatter plots. You're looking at the data, and you're just trying to see what it's... I won. Loser. You're just trying to see if there's any patterns amongst the data, okay? And it's really important that, first of all, you understand what this point means. For example, this point means if the dog is 21 inches tall, dog weighs approximately 24 pounds. I'm not going to do the homework because I'm being kind of lazy, so